Jai Hind, dear students. I'm Dr. Preeti Mittal, and today we are going to have the second part of the chapter Chemical Reactions and Equations. In the previous chapter, we have seen about the balancing of chemical equations, which could be a very important question for you all in your final exams. It can come as a 3 marks question, and you could be given 3 reactions to balance them. Then we have seen about the combination reaction, exothermic reaction, endothermic reactions, and decomposition reactions. So these 4 type of reactions were discussed in the previous video. If you haven't already seen that, you can go through those. Now we will be discussing about the next types of reaction. The first one being displacement reaction. Displacement word only suggests that one thing is going to replace something else. Okay, one of the elements will be displaced by another one. Which element is going to displace the another one? That you can easily make out from the reactivity series. Okay, so we will be studying about displacement reactions. For studying displacement equations, displacement reactions, you should remember the reactivity series which we have discussed in the previous chapter, metals and non-metals as well. Okay, so you should be aware of the reactivity series. What is the reactivity series? First time, I'm just writing it once again here. Karan ne car मांगी, ऑल्टो जेन फरारी, पापा बोले हंगामा क्यों होगी आगे और पिटाई. So this is the reactivity series, and a more reactive element can displace a less reactive element from its salt solution, and that is the definition of displacement reactions. So one example we'll see. You can see iron is more reactive than copper. So if you react copper sulfate solution with iron, what will be formed is ferrous sulfate and copper will be displaced. How will come to know that this reaction has taken place? A color change will be there. Copper sulfate is blue in color, whereas ferrous sulfate is having greenish color. So there will be change in the color of the solution, and by that way you can come to know that the reaction has taken place. If you take copper sulfate solution and put some iron nails into it, you will see that the blue color of the copper sulfate solution is going to fade away. It is going to form greenish in color, and apart from that, on the nails this copper will be deposited. So if you have taken some nail means in Hindi we call it as keel. So if you take an iron nail and that dependent copper sulfate solution, you will see that a layer of copper will be deposited over this nail, and that will show that this displacement reaction has taken place. A similar displacement reaction could be there in case of, for example, we can take aluminium being reacting with Fe2O3. I hope you remember this reaction. We have studied this in metals and non-metals chapter also. So aluminium being more reactive than iron, it's going to displace iron. You can see. So it's Al2O3 formed and Fe is formed, that is in liquid state. So this reaction is very important for your exams because this reaction is a displacement reaction also. This reaction is a thermit reaction also, and this reaction is a exothermic reaction also because heat is liberated out. Remember, displacement reactions are always exothermic in nature, means they are going to release heat. How you can remember that? Very easy way. If someone removes you from your place, आप बैठे हुए हो, आपको हटा कर कोई और उस आपकी जगह ले ले, and you are pulled out of your place, then you'll be really angry with that thing. Okay, अगर आप गुस्सा होगे तो गुस्से से गर्म हो जाओगे, और ये सॉल्यूशन भी ऐसे ही गुस्से से गर्म हो जाता है because copper is displaced by iron from its solution. Okay, so that is just one way to remember that. And this also we have seen, this is a thermit reaction used for repairing of railway tracks where molten iron was formed, because such a lot of heat is produced that the iron formed here is molten iron, and so this is a highly exothermic reaction. So remember, displacement reactions are exothermic reactions. And displacement reaction is when a more reactive element displaces a less reactive element from its solution. Next, we have double displacement reactions. For double displacement reactions, we don't need this. Shall I tell you one more example of displacement reaction that is given in your book as in theory part, but not given as a reaction form. So I'll be telling you that as well. So we have taken first we'll take lead iodide, potassium iodide, and we make it to react with lead nitrate. Lead nitrate, if you remember, PbNO3 hold twice. Then what will be formed? Lead iodide will be formed plus potassium nitrate is formed. This reaction is given in your book, but only in the words, not as a reaction. Okay, so remember this as well. Potassium iodide reacts with lead nitrate to form lead iodide plus potassium nitrate. You can balance this reaction. So here we have balanced it. Nitrate should be 2. So here potassium is also 2. So we have multiplied it with 2 here. Okay, we have to check that the number of atoms of all the elements on the right and left side are equal. Then only it's a balanced reaction. Okay, so here lead iodide, potassium iodide reacts with lead nitrate to form lead iodide and potassium nitrate. This is a double displacement reaction. Sorry. The next type of reactions I've started with, sorry. The next type of reactions that we are going to study right now is a double displacement reaction. In double displacement reactions, there is exchange of ions between the reactants to form new products. So how the exchange of ions is going on, one example I have written here. And here what is going on, that potassium was having the bond with iodine, but now potassium is forming the bond with nitrate. Here lead was having bond with nitrate, and now here in the react products lead is forming a bond with iodine. So there is exchange of ions. I will define double displacement reactions, very important. Remember that in double displacement reactions there is exchange of ions between the reactants to form new products. Okay, so this is an example of the next type of reaction, that is double displacement reaction. One more example of double displacement reaction I would like to tell you. Na2SO4, that is sodium sulfate, when reacts with barium chloride BaCl2 forms NaCl plus barium sulfate BaSO4. We need to balance that. So here's 2 sodium ions were there. So 2 sodium atoms has to be here also. Now chlorine is balanced, barium is balanced, and sulfate is also balanced. Okay. So this is another example of a double displacement reaction when sodium sulfate reacts with barium chloride to form sodium chloride and barium sulfate. This is another example of double displacement reaction. Now, very important thing. Just remember the example of any two double displacement reactions for your exam, because you could be asked to define double displacement reaction with two examples. You know, most probably they are just going to expect you one example from you, but on a safer side, remember two reactions, because the reverse of this is not true. Here, NaCl is a very strong bond, having a very strong bond with sodium, is having a very strong bond with chlorine. So, the reverse of the reaction is not possible. And this is a white colored precipitate. This barium sulfate formed is a precipitate. It's in the solid state. Okay, this is in the solid state. Rest of everything is in its aqueous state. Here also it's aqueous. Since barium sulfate is solid and NaCl is having a very strong bond, so the reverse reaction is not possible. So you cannot write barium sulfate reacts with sodium chloride to form these things. This is wrong. Okay, so the reaction has to be written like this only. In the above reaction also, lead iodide formed is a precipitate. Okay, so such reactions in which some solid products is dissolved in the liquid, such reactions are known as precipitation reactions. The reactions in which some precipitate is formed, such reactions are known as precipitation reactions. So we have studied about double displacement reactions as well as precipitation reactions. Okay, in both the reactions you can see that barium sulfate was formed, that is a precipitate. Here lead iodide is formed, here this is a precipitate. So you can take a screenshot if you want, because this, the first reaction it's not given in your book. Okay, so next we are going to talk about oxidation and reduction. Again, one of my favorite topics, very interesting to know. Oxidation and reduction. Oxidation and reduction, I'll tell you with one example. For example, magnesium combines with oxygen to form magnesium oxide. To balance it, I'll just do that. Okay. Here, magnesium is combining with oxygen. So, this type of a reaction is a oxidation reaction. What is happening with magnesium? Magnesium is undergoing oxidation. What is happening with oxygen? Oxygen is undergoing reduction. Oxygen is undergoing reduction. So simply for remembering for your exam purpose, you can remember that whenever oxygen is added up, so that is oxidation. And when one substance undergoes oxidation, when one of the reactants undergoes oxidation, another reactant undergoes reduction process. Okay, so such reactions are known as redox reactions. Redox stands for RED for reduction and OX for oxidation. RED stands for reduction, OX stands for oxidation. So such reactions are also known as redox reactions because reduction and oxidation are going on simultaneously. Similar reaction happens when we heat a copper ribbon. Okay, suppose you have a copper element with you. You all know it's brown in color, coppery color. That brown color is there. So if you heat it in air, that is going to combine with oxygen present in atmosphere to form copper oxide, that is going to form copper oxide. So oxidation of copper is there. But what happens if you pass hydrogen gas to this heated element? Okay, you have heated copper, it reacted with with oxygen. So this was having the brown color copper, and copper oxide formed is black in color. But now if you pass hydrogen gas through this heated element, then what will be there? Copper will be formed again and water will be formed. How you will come to know that copper has been formed? That is, brown color will be reappearing. Okay, brown color will be reappearing. So in this reaction, if we see what is undergoing oxidation and what is undergoing reduction, let's find it out. Oxygen is removed from copper oxide. So there is reduction of copper oxide and there is oxidation of hydrogen. So hydrogen undergoes oxidation and copper oxide undergoes reduction to form copper. Okay, so these are two examples of redox reactions that we have seen. I'll just let you know one more reaction. In this reaction, we are going to react manganese dioxide with hydrochloric acid. Okay, when they are going to react, what will be formed is magnesium chloride plus water plus chlorine. Okay, this reaction is also given in the book. How, what is undergoing reduction and what is undergoing oxidation, that is also given in the book. So let's see that. Magnesium oxide, from magnesium oxide oxygen is getting removed, so it is a reduction process. So that is a reduction reaction. And here from HCl, chlorine is being formed. Removal of hydrogen is known as oxidation. Adding of oxygen is oxidation. And sorry, adding of oxygen is oxidation, and removal of hydrogen is also oxidation. So here hydrogen is being removed, so we will call it as oxidation. So here hydrogen is removed from HCl to form chlorine gas. So that is the oxidation process. And here from manganese dioxide MnO2, oxygen is removed. So removal of oxygen is reduction. Okay. Adding of oxygen is oxidation. Adding of oxygen is oxidation. But removal of oxygen is reduction. Okay, fine. Similarly, adding of hydrogen is reduction, and adding and removal of hydrogen, removal, if hydrogen is removed, removal of hydrogen is also oxidation. Okay. Apart from that, I would like to tell you one more thing, that not only oxygen, not only hydrogen, they are going to define that the reaction is oxidation or reduction. We can also understand these redox reactions on the basis of electron gain and loss. Or just I'll explain you one more example. For example, magnesium combines with chlorine to form magnesium chloride, MgCl2. Okay, so in this reaction there is no oxygen. So is it a redox reaction? How can we explain that what is going undergoing oxidation and what is undergoing reduction? So here oxygen and chlorine both are electronegative. So remember that whenever you see chlorine, whenever you see oxygen, or whenever you see any other electronegative element, when some electronegative element is getting added up with something, that element is undergoing oxidation. And what is happening with chlorine? That is undergoing reduction. This last reaction is not given in your book, but I always like to tell this because this is something that you should know as a concept. Okay, so if you find it difficult, you can skip this one out. Okay, one last reaction that's very easy is sodium reacting with oxygen to form sodium oxide. This is also, you can easily find out that sodium undergoes oxidation because oxygen is added to sodium, and oxygen is undergoing reduction because oxygen is added up with sodium. Okay, so जिसका खुद का रिडक्शन होता है वो और दूसरे वाले का ऑक्सीडेशन होता है. Okay, when one thing is getting oxidized, the other one is getting reduced. Remember that. So by that way, you can easily find out whatever is the oxidation and reduction. The next topic is about corrosion. We are just left with two topics, corrosion and rancidity, and then we will end up with this video. In the next video, we will study about more from the questions that are given in your NCERT book. We'll discuss all the questions given in your NCERT book. Especially, we'll work out many equations that are for balancing, and we'll see that one particular reaction could be of different types. So what type of reaction is that? Okay, so we'll just study all that in the next video. But for this video, the second last topic is corrosion. Corrosion means when the metals are reacting with oxygen, carbon dioxide, water present in the atmosphere, and they form some compounds and that degrades the value of that metal, that is known as corrosion. For example, iron undergoes rusting because iron combines with moisture and air, and it going to form that rust. Apart from that, when silver undergoes corrosion, it combines with sulfur present in the atmosphere and it forms a silver sulfide. Similarly, copper forms a layer of copper carbonate because it's a greenish layer. You must have seen on the copper vessels at your home also that a green layer is formed. That is because of copper carbonate formed because copper reacts with carbon dioxide present in the atmosphere. Okay, so these are all about corrosion. We have studied corrosion in much more detail in metals and non-metals chapter. you can go through that also. We have seen the ways to prevent corrosion also in that. Okay. Now next is rancidity. Rancidity is also very important. Rancidity. What is rancidity? Rancidity means when the food items are containing some fats and there is oxidation of the fats present in these food items, that is known as rancidity. So I will define that. The oxidation of the fats present in food items is known as rancidity, and it leads to change in the taste and smell of the food items. Okay, it is independent of moisture. Don't say that when the chips packet are let open and it will react to the atmospheric moisture, then it is going to become unfit for eating. That is rancidity. No, it's the wrong answer. Okay, it's about the oxidation of fat present in the food items. How you can prevent rancidity? You can delay rancidity by storing your food items in airtight containers so that it doesn't get oxidized, it doesn't get come into contact with air. And the chips manufacturers do a very good thing, that they flush the chips packets with nitrogen gas. Why nitrogen gas? Nitrogen is a non-reactive gas or an inert gas. It's not going to react with the fats present in the food items, and so it will prevent rancidity. So to prevent rancidity, either you can store your food items in airtight containers, or you can in the especially in the chips packets, or whatever ready to eat food items are available, in that also the packet is flushed with nitrogen gas, which is inert gas, to prevent rancidity. Okay, so I hope you are clear with the chapter. In the next video we are going to discuss the questions, but for this video that's all for today. Good day everyone, keep practicing and scoring well.